we're going to go ahead and take a look at the difference of proportions and how to work with a situation where we're trying to compare the difference between two proportions. So this is the outline of the things that we'll be covering in this video and this lesson. So one proportion or two. Two proportions have two totally separate categorical variables, where one proportion, there's only one categorical variable that you're dealing with. So decide whether this one is one proportion or two proportions. So pause the video and answer the question. It's really only one proportion. You either use a Windows-based PC or a Mac-based PC. It's one or the other. It's type of computer that you're using is one categorical variable. So what about this one here? And this would be two categorical variables because public or private university and study abroad or not study abroad. This one here. This is one proportion. You're either in state or out of state. If you're not in state, that means you're automatically out of state. So you only have one variable that you're dealing with. And then this one. And this would be two because you're in state or out of state. And the other variable is financial aid or no financial aid. So our standard error for the difference in two proportions is given to you by this. So we take our first proportion times 1 minus that first proportion over the sample size of that first proportion. Then we take our second proportion times 1 minus the second proportion over the sample size of that second proportion, all inside of a square root. Now, the central limit theorem says that the difference in our two proportions will become normal. That's what this n in front means. And this is the difference in our two proportions. So that's where it's going to be centered for our mean. And this is going to be our standard error over here. Now, we need to make sure that the central limit theorem applies. So if n is large enough. So all four of these have to be true. So your proportion, first proportion times the sample size of that has to be greater than or equal to 10. The sample size of that times 1 minus that first proportion has to be greater than 10. And then for your second sample size times the second proportion has to be greater than or equal to 10. And your second sample size times 1 minus that second proportion needs to be greater than or equal to 10. Basically, you just want to make sure each cell has at least 10 in it. So, consider this situation. If we take a random sample of 100 males and 100 females, what will be the standard error of the differences in our proportions? Go ahead and try to calculate that. So we're going to take our proportion of women times 1 minus our proportion of women over the sample size of women plus proportion of males plus 1 minus the proportion of males over the sample size of males, all inside of our square root. And we get approximately 0.06 for our standard error.